Okay, let's fill out this graphical organizer to remind you everything about a square root function and a cube root function. So, again, the parent function, f of x is equal to the square root of x, and it contains the points 0, 0, 1, 1, 4, 2, and 9, 3, and looks like the graph at the right. Your domain for a square root function, you can only find the square root of 0 to infinity, and you're only going to get values, since we're talking about the principal root, of 0 to infinity. The endpoint or the starting point for this graph is the origin. Now, some transformations, if we were to take that graph and do a +1, that would move it left 1, and a -3 at the end would move it down 3. That's your original function, which I'm going to graph again. And you would just take every one of those points, you'd move them all right 1 and down 3, and now it would look like this. And that would be left 1 and down 3. I can't remember if I said right 1 or left 1. Left 1 and down 3. The domain of your new function, since you moved it left 1, would now be from -1 to infinity. The range, since you moved it down 3 instead of 0, would be now -3 up to infinity. And the endpoint, again, got moved left 1, and it got moved down 3, so it is now located at -1, -3. Example 2, the transformations that's happening here from your parent function. This negative would flip it across the x-axis. That's a vertical flip, and then you'd move it up 6 units. So again, your original function would look like this. And if you were to take every one of those points and flip it across the x-axis and then move it up 6, it would then look like this. And you can see there that those points got flipped first and then moved up. Your domain of your new function, still the same, 0 to infinity. Why? Because the stuff under a square root is still just plain x. It did not get moved left or right. Your range, however, now goes down forever to -infinity. This thing keeps tapering off, down, down, down. And it goes up to this highest point, which is now located at 6. And that is a point on your graph. And that endpoint is located now at 0, 6 because it got moved up 6 units. Your cube root function. Your basic parent function of a cube root is f of x is equal to the cube root of x, and it looks like this. The domain of a cube root function is all values. You can plug in anything from negative to positive infinity. Your range, your graph goes down forever to the left and up forever to the right. Your turning point is also going to be the origin right there in the middle. That's going to be kind of like our vertex. Let's take that exact same function and let's perform this transformation. That's going to take your original function and move it right 2 units. So let's graph your original function. And there it is. Now let's take every point on it and let's move it to the right 2, every one of the points, and this is what it's going to look like then. And there would be your new function. Again, it just got shifted to the right. Your domain is still going to be the same, and your range will not change. Because it's still an infinite. Your turning point, the only thing it changed is your turning point. Again, got moved right 2 units, so it is now located at 2, 0. Last example, 3 different transformations here. We're going to do a vertical stretch because it's on the outside times 2, so it's going to make it twice as tall. Then we're going to move it left 5 and up 4 from our original function. So let's go ahead and graph our original function first. And there it is. Now, when you do this transformation, make sure you stretch first, and then you're going to move left and up in the next step. So let's do that to all of our points and see what it looks like now. And there's a look at your new graph. Your graph's domain still goes left and right forever, and its range still goes down and up forever. Its turning point got moved from 0, 0 to now appear at a -5, -4, which again we can find just by looking at where the translation happened.